we go. This is adding and subtracting rational expressions. Same thing we did before, but I'm just going to tackle it in a different way. Yeah. Oh, I didn't? Oh, kidding. Just kidding. Okay, so here we go. To add and subtract rational expressions. Step 1, factor each denominator. Step 2, determine the LCD. Step 3, build the common denominator. Step 4, add or subtract the numerators and place over the common denominator. Step 5, simplify as possible. So my idea here was, let's use a strategy you've learned in a previous course. Back in geometry, you guys did a 2-column proof. And so I'm not going to ask you to do 2-column proofs in here, okay? That's not what I'm asking. But I wanted you to see, I worked out the first example for you. But what I thought we could do together is think about why are you allowed to do what we're doing. Then, on the next side, I'm going to leave some blanks so that you have to do some of the statements and then some of the reasons. And then we'll go where we do them on our own without the 2-column proof. So the 2-column proof is just another way to kind of lead you through the steps. And if you like it, you can choose to use that strategy. If you don't like it, you don't have to use it. But it's kind of a neat way to look at this. So if you remember from geometry proofs, when you start with the original statement, what was the reason? Given. Nice. Okay, so when you start with a given, that's the original statement. Now what I want you to do is I want you to look from statement 1 to statement 2 and try and figure out what did I do. Yeah, Sarah? Yeah, I just factored the 7x out. So we're just going to say the reason is I factored. All right, now, in step 3, what have I done, Joe? Okay, that is certainly true, but that's not actually what I'm doing. What did I actually do to this first fraction? What's, yeah, what? Okay, but I didn't just multiply 3x. Haven't I multiplied by 3x over 3x? Which is 1, right? So you're right, Joe, you weren't off the mark. I am finding the LCD. That's certainly what's going on. But the technical step is I multiplied by 1 and I multiplied by 1. That's my reason. I'm actually multiplying by 1. But you're absolutely right. The big picture is I'm developing the LCD. Yeah, Joe? All right, number 4. What did I do next? What can you tell? You just multiplied, right? I took 2x times 3x. It gave me 6x squared. And I did 4 times 7 is 28. All right, now what did I do from step 4 to step 5? I did the distributive property, right? I took the 28 times the quantity x minus 1 to give me 28x minus 28. All right, then what did I do? Yeah, you can say you combine terms, simplify, add. Any of those statements would be okay. All right, so now what I want you to do is I want you to flip it over and I want you to look at this 2-column proof. And I left some of the statements blank and some of the reasons blank. What I'd like you to do is do as many of them as you can figure out. But before you look at it and say, I can't do it, I want you to flip back to the example 1 and look at, hey, what did we do there? What did we write? What did that mean? And let's see how many of these you can actually figure out. Because I think you can. So I'm still going to let you work, but number 1, everybody should have been able to fill that one in. When your reason is the given, that's the original problem. Number 2, Meredith, what'd you say for 2? What'd I do? Yeah, okay, so 2 is factor. And I love what I'm hearing. I'm hearing you flip your papers back to example 1. That's exactly what you want to be doing. So step 3 says I want to multiply by 1. And we talked about in example 1, yes, it's building the LCD. So in number 3, what am I going to multiply the first fraction by that's a 1? Not an x minus 2, no? Yeah.
3x minus 2 over 3x minus 2.
No. Not x minus 1. Just 3 over 3, right? Because the LCD is x minus 2, x minus 1, 3. You don't put the x minus 2 twice, unless it's to a second power somewhere. If the factor appears on both, you only take it once, unless one of the 2 factors has a higher power. Then I'm going to take the second fraction, And what do I have to multiply that one by? That's a 1. X minus 1 over x minus 1. And you guys, there should have been a clue in step 4. Did you notice that? Do you see that? If you look at step 2 to step 4, how did we get there? The only thing that's new is a 3 and a 3. And here there's an x minus 1, x minus 1. All right, step 4. I'm just multiplying. Step 5. What did I do here? I did 2 things. Distribute in the first one. And then what did I do with x plus 3 times x minus 1 to give me this? What's that called when I multiply it out? It's not technically it is the distributive property. You need a name when you take a binomial times a binomial. FOIL, right? That's FOIL. Okay, that's FOIL. So I distributed and FOILed. Now, number 6, I gave you the reason is the distributive property. Well, the only thing I can distribute is the minus sign. Okay, step 6 says distributive property. Well, the only distributing I can do is that minus sign. All right, for the reason in 7, what have I done from step 6 to step 7? Combine like terms. Okay, combine like terms. All right, now 8. This one might be tricky, but what did I do? I factored. I factored a negative 1 out. Factor out the negative 1 in the numerator. Then step 9 says factor the numerator. That's x plus 6, x minus 1. And then step 10 says cancel common factors. So I'm going to cancel the x minus 1s. And you can leave it factored or you can multiply it out. It does not matter. So, in example 1 and example 2, I wanted you to see worked out problems that we talked about the steps. Like, what are we doing? What math properties allow me to do that? I'm allowed to cancel common factors. You're never allowed to cancel terms. Like, I cannot cancel the x's here because they're terms. X plus 6 is a factor. X minus 2 is a factor, but x's are terms in there. All right, but I will never ask you on a quiz or on a homework to do a 2-column proof, okay? So, but I just thought this would be a neat way to see it, a different way than how I explained it yesterday. All right, so here we go. Let's look at example 3. Step 1 is factor each denominator. Well, the first denominator can't be factored. It's just x minus 1. But the second denominator is x minus 1 times x minus 2. So I'm going to determine my LCD. What is the LCD here? It's x minus 1 times x minus 2. It's not x minus 1, x minus 1, x minus 2. You only need the x minus 1 once, okay? Then I'm going to build the common denominator by multiplying by 1. The second fraction already has the common denominator. So I don't need to do anything to my second fraction because it already has the LCD. But my first fraction is missing x minus 2. So I'm allowed to use the multiplication property of 1. So this is x times x minus 2 over the common denominator. put it over the common denominator and say x squared minus 2x plus 2x minus 1 then you combine like terms, so you can like see the connection to our 2-column proof steps. So I combine like terms, and then you want to see if it'll factor, and this does. X squared minus 1 is a difference of 2 squares, and I can factor my I can cancel my common factors and get x plus 1 over x minus 2. I cannot cancel those x's because they're terms. Let me go back to my restrictions because that'll help me when I solve rational equations in 8.6. So x can't be 1 or 2. All right, what I'd like you to do now is I want you to flip it over and I want you to try the next 3 on your own. I've put the answers on the side board. So I want you to work it out, check it. Work it out, check it. First, before you ask me to help you, I want you to look back through your notes. And you guys were doing a really good job with that from example 1 to example 2. Look back at the other problems and see if you can figure out where you made your mistake. I am going to, just because I've got my recording going, I'm going to work these out rather quickly. Turn off the recording, and then I'll talk about any of those that you might need. Okay, so don't watch the board. You work on it yourself, okay?
What?